civil engineer. Okay, if it's your first time, before we continue with our lesson on modeling and designing and providing enforcement of a G+4 residential building, I would like to encourage you to subscribe to our channel to show us some love by leaving a like also, and also leaving a comment. Okay, don't forget to subscribe to our various platform, okay, social platform, okay, social media platform. Okay, thank you. So last time we ended our lesson on the modeling of the foundation beam. So today in this new lesson we are going to continue directly with the orientation. We first of all check the orientation of our dwarf pillars. Okay, so we'll go on plans, then we'll come here. First of all, you realize that the formwork plan has changed. Okay, so the last time we started with something without a formwork plan. So this is a formwork plan that I find out in one of my documents. So we'll be using it for this project. Okay, so as you can see, it's the exact one that I've modeled to the level where we ended. So today we are going to talk about the orientation of this column. Okay, one thing that you have to notice that on this homework plan, the columns are all square column. Okay, they are all square column, but on the project we decided to work with a rectangular column. So the orientation of this kind of column does not matter, but for rectangular column we make it in such a way that the width of the rectangular column should be oriented following the long span. That means this short side of the column, okay, this short side of the column should be oriented. If this is the longest span in between, if you compare this span of the beam 26 and this span of the beam 41, the longest one, which is surely this one, the short side of this our column should be orientated following this side. Okay, that's what it means. Okay, so the width of this column should be following aligned with this long span. It's a mechanical principle to show that to reduce the effort that will be done when we will be applying the slab here, the the slab here. Okay, a rebuild slab, because if this is the long span, obviously we'll be sending the rebeam this way like this. Okay, they will be orientated along this short span, and obviously this column will have a certain deflection at this level which will influence this column here. Okay, so it's a mechanical principle that you have to check. I've done it before in one of the video, the orientation of columns. Okay, rectangular column particularly. So to check that, we'll go on tools, we'll take dimension, we'll measure this span. Okay, to avoid having I miss it. Okay, so let's take it back. We'll click here, we'll click on this other joint, we'll click on this other, then we'll put the dimension. Okay, so we'll ensure that the dimension to be able to control our span every time. Okay, to ensure that we are not making errors. Okay, so is it, come here and put also the dimension on this side. Okay, quickly put the dimension. Okay, that's it, we are done. So let's I would like us to delete this one. Okay, let's draw it back. Dimension line, you go on to, you click on dimension, then you choose the dimension. Okay, that's it. Okay, so we have all the spans. Now we compare for a column that is in the junction of only two beam, like this beam and this beam. Okay, we compare the span. You will notice that this span is longer than this other, which is 350. Okay, so the column is already well positioned because the short side of the column is aligned following the longest span. Okay, now when we come on this kind of column which is the intersection in between three beam. Okay, what we do is that we take the column, the beams that are aligned following the same direction. For this our Cartesian repair, we'll notice that is along the x-axis, as you can see down here. So we are following the x-axis here. We'll subtract this span from this span, or this one to this, but we'll take the absolute value. Okay, so subtraction of 393 minus 388 will give you about 0.05, that's 5 centimeter. Now compare it to this man only, to his span, because there is no another beam, there is no beam continue this way. Okay, so you have 3 meter 50 to compare with 0.05, that's 5 centimeter. Obviously the 3 meter 50 is the biggest span. So we'll click on this column, dwarf column, then we'll come here on the object inspector, we go down to gamma here, we'll enter 90 degree, and then we'll press enter on the keyboard. Okay, that's it. The column has changed, is aligned now following the short side of our column, which is a rectangular column, is aligned following now the longest span, that's been 58 in this case. So now let's take this other scenario where we have a column intersecting four beam. Okay, so you take the people along the same axis on the y-axis like this. On this axis, in this direction, is following the y-axis, as you can see on our Cartesian frame down here. Okay, so you will take this span 3 meter 50 minus 3 meter 18, it will give us about 32 centimeter. Okay, now you subtract also 3 meter 93, okay, which is for beams 44 here, minus 3 meter for minus 3 meter 88, which is beam 42 here, and then you obtain the very 5 centimeter that we obtained for the subtraction up here. So you realize that 5 centimeter compared to the 32 centimeter difference that we obtained from 3 meter 50 and 3 meter 18 here is smaller. So we orientate this dwarf pillar following this direction, the y-axis direction. Okay, we'll make in such a way that the short side or the width of the column should be oriented following that direction. Okay, so we'll come again on the object inspector, we'll press enter. Okay, that will be it. So that's what we are going to do all over through this column, to check it all over and ensure that we align them following this principle. Okay, is very important. So thank you for watching. See you soon for the next lesson. We'll not keep it long, so that the video should not be too long. So, and stay connected on our various social media platforms to have the next part. Okay, it was Andrew. See you soon.